Hello. Okay, we can start now. We can start now. So before starting, we can first recap what we have seen in last week. I mean this week. Okay. So it is all about the distortions in the welding. So what is the distortion is that change in the shape, the any unwanted physical change in the welding structure called as a distortion. Okay, that is like it is bending, it is twisting, like for example, ideally we want to do the have the weld bead appear like this way, but once the parameters are welding conditions are not appropriate, then the weld bead may, instead of weld bead should be look like this way, it will be look like, this way. So it is deflection in the dimensions. This is called as a distortions. Okay. Usefulness of the component may be affected because of the, if I want a proper dimension, it may not be compatible with the other components because of which dimensions have changed, and additional cost required to rectify the component. If the deflection happens, then we have to do some mechanical or thermal processing to reduce these deflections. That will also add the cost in the production. So distortion caused by non-uniform expansion and contraction of the weld metal adjacent to base material during heating and cooling cycle. So it is mainly due to the non-uniformity of the heating and cooling. So as we seen in previous lectures, if we have the heat source, how the heat profile will be look like? It will be look like this way. So above portion it will be heating up. That means it will be the expansion region. and here it will be the cooling takes place, it will be the contraction. The weld is happening in this direction, so here it will be the expansion, here it will be the contraction. This may result in the residual stresses. If the component is deformed, then it will forms in the distortions. Okay, next. Okay, there is a three stages in the this distortions. Okay, one is the during the expansion of the surface, how it will be from the 100 degrees. For 100 degrees it will change by 0.7 to 0.8 percentage, and solidification shrinking. So during the here molten material is there, this is once it got solidified, it will be start shrinking, that will reduce results in the compaction. So that compaction change may be up to 3 percentage, and solid shrinkage, that is the anti this component heating and followed by cooling, that will be results in the solid shrinking, that is may up to 7 to 3.5 percentage. Okay, the factors affecting the distortion in welding are mainly due to mainly by different properties, such as a metal properties like thermal coefficient of expansion. Suppose if you case two materials, one is iron and one is aluminum. Aluminum has the more thermal coefficient of expansion. So that means that will have a more deflection we can observe. Okay. But in the case of iron, it is compared to aluminum, it will be bit less. Okay. Similarly, thermal conductivity. If thermal conductivity is high, then the whatever the heat is generated at the welding pool, that will be immediately dispersed. So that when the thermal conductivity increases, the distortion effect will be less. Okay, if the thermal conductivity is less, so the heat gradient will be much more higher, so that the deflection will become much more higher. Okay, similarly, yield strength. If the yield strength is high, the amount of the distortion will become more. Okay, similar modulus of elasticity. If the elasticity modulus of elasticity or stiffness is higher, so the deflection will become less, because if it is more stiff, it will be the less prone to deflection. Okay, similarly, some of the welding process and parameters also will be affecting, such as the amount of the weld metal we are giving. Suppose if we depositing the more amount of the weld metal, so that will result in the more deflection. So always we have to prefer to go with the low amount of the weld metal. And welding speed, if we increase the welding speed, the uh, the deflection will be less. If the welding speed is low, the deflection will become more. Okay, next, what is the type of welding distortions are there? Those are the longitudinal shrinking. So if the longitudinal shrinking means, it is the shrinking happens in the length direction of the weld metal. Okay, and transfer sinking, it is happen in the cross sectional way. Okay, so here you can see it is the longitudinal shrinking. Here this is the weld metal, so it is shrinking in the this longitudinal direction. This is called as a longitudinal shrinking. In transverse shrinking, the actual dimension is this dashed lines, and it is shrinking in the uh, cross sectional transverse direction. Okay, and this is the angular distortion. So it is moving in, it is deflecting in a certain angle. Okay, similarly, it is the rotational distortion. So here is the weld bead. These two plates are moving opposite to each other, whether conversely or divergently. Okay, this is called as a rotational distortion. And similarly, buckling is happen in a certain way pattern for the thin sheets and so on. Okay, so now we can see the some of the problems, problem solving. Okay, so which of the following is the dominant mechanism responsible for the welding distortion? So what is the dominant mechanism? Elastic deformation, plastic deformation due to thermal gradient, phase transformation only, or grain boundary diffusion? Answer will be, it is due to plastic deformation. it is permanent deformation, so it is plastic deformation due to thermal gradient. So Weldon distortion mainly arises from the non-uniform thermal expansion and contraction, which leads to plastic deformation when the yield strength exceeds the at higher temperatures. Okay. Next, angular distortion in the butt welding is primarily caused by uniform heating across the thickness, unequal contraction across the thickness, extended external loading, and residual stress relief. Answer will be B. Unequal contraction across the thickness. Okay. The weld zone experiences the high temperatures than the base material, causes the unequal shrinking through the thickness, results in angular distortion. Okay. So it is because of if it is the uniformly expansion is taking place, there will be no deflection because the entire component will be expanding uniformly or contracting. But if there is a ununiform contraction or expansion, that results in the deflection. Okay. A long weld bead deposited on the plate most likely caused by transverse sinking only, longitudinal sinking only, both longitudinal and transverse sinking, and no shrinkage. So answer will be both longitudinal and transverse shrinkage. Okay. So why it is a welding caused in contraction both direction along the longitudinal and transverse direction. Okay. Next is the which of the following welding technique minimizes the distortion. Okay. So high heat input welding, continuous welding from one end, and skip welding sequence and increasing the weld size. So answer will be C. Okay. The skip welding. So skip welding distribution of the heat is more even and reducing the accumulation of the thermal stresses and distortion. Okay. So how the skip welding? I think previous classes we have seen. So how the skip welding takes place? Suppose if I have to do welding here, this region. So first we will do up to certain portion, then we will skip to other location and other location so that the thermal distribution will become more, the thermal stresses will become much more lesser. So which results in less distortion. Okay, next. The magnitude of welding distortion is directly proportional to option A yield strength of the material, option B heat input per unit length, option C plate thickness, option D cooling rate. Answer will be option B. It is the heat input per unit length. So higher heat input per unit length results in the larger heat zone. that is, and greater thermal expansion and contraction that increases the distortion. Okay. Next is the which type of the distortion is associated with buckling the thin plates. Okay, that is the I think it is angular distortion, longitudinal shrinking, transverse sinking, out of the plate distortion. Answer will be out of the plate distortion, nothing but a buckling. That will be the answer will be the D. In tin plate often experiences the buckling uh, distortion due to the compressive residual stresses. Next, residual stresses in weld joint are mainly due to external mechanical load, non-uniform plastic deformation during cooling, corrosion effect, and magnetic forces. Which one is the answer? I think it is also already we have seen. Answer will be the B. It is the non-uniform plastic deformation during the cooling. Okay. So residual stresses develops because of the different regions cools and contracts unevenly causes the plastic deformation constraints. Okay. Next, for reducing the distortion in the welding, which of the following is not effective? Which is the not effective? Uh, First is the preheatment of the workpiece. Yes, if we do the preheatment, it will reduce the amount of the distortion. Option B, usually smaller weld pass. So it is the contrary. So if we use the smaller weld pass, it will reduce the distortion, and if we increase the bigger weld bead and multiple passes, it will increases the distortion. Option C, increases the weld speed. If we increase the weld speed, it will be reduces the distortion, and if we decrease the weld speed, then it will increases the distortion because of the thermal difference is much more higher, and increase the heat input. If we increase the heat input, that will result in increase in the uh, distortion. So answer will be the option D. So increasing the heat input worsens the distortion by increasing the thermal gradient and shrinkage. Okay. The term inherent strain in welding distortion analysis refers to elastic strain only, plastic strain only, some of the plastic thermal and transformation strains, and external applied strains. Answer will be C. Inherent strain including the plastic strain, thermal strains, and plastic paste transformation strains, which collectively causes the distortion. Okay. Which of the following factors has the least effect on the welding distortion? Okay. I think it is a bit obvious question. Joint design, B, welding sequence, ambient light conditions, metal properties. So answer would be C. It will be the so distortion influenced by thermal and mechanical factors, not by the lightning factors. Longitudinal distortion in the welding occurs due to shrinkage along. Longitudinal distortion means it should be shrinking along the welding bead line. That will be thickness direction, width direction, length of the welding, or diagonal direction. Answer will be C. It is the length of the welding. The transverse direction is primarily transverse distortion is primarily caused by shrinking along the answer will be option A, shrinking along the welding axis, shrinking perpendicular to the weld axis, external loading, phase transformation. Option will be perpendicular to the weld axis. So the transverse distortion occurs perpendicular to the weld line due to the contraction across the joint. Which of the following parameters has the greatest influence on longitudinal shrinking? So, which of the following parameter are the greatest influence is that one is the plate width, weld length, plate thickness, and joint angle. Okay, for longitudinal shrinking, which is the affecting parameter, it will be the weld length. So, the longer the weld, the more total contraction occurs along the line, increases the longitudinal distortion. For a given heat input, which plate is the more susceptible for to transverse direction? It is the thick plate, thin plate, elastic plate, or hardened plate. Option will be thin plates because thin plates often less resistance to deformation, so they distort more easily in transverse direction. In butt welding of the two plates, the transverse shrinking results in increase in the plate thickness, reduction in the plate width, elongation in the weld, no dimensional change. I think it is also so it will be the answer will be B. Transverse shrinking pulls the material towards the weld center line, reducing the overall width. Which welding sequence more effective in reducing the longitudinal distortion? So continuous weld from one end, back step welding, random welding, and reduction in increasing weld size. So answer will be the back step welding. In back step welding, as you see, so we will do the one pass forward, then again we do the one pass opposite direction, so that the stresses which are generating here will be complemented by these stresses, so which makes it uniform, less residual stresses that results in the less distortion. So backstep welding distributes the heat more evenly, reduce the accumulated shrinkage along the weld. The ratio of the transverse shrinking to longitudinal shrinking generally greater than 1, less than 1, equal to 1, 0. Answer will be A, greater than 1. Transverse shrinking is usually greater because contraction occurs across the weld is less constrained compared to along the weld. Which factor reduces the both longitudinal and transversal distortion? Increasing the heat input, using the intermediate weld, decreasing the weld speed, increasing the weld size. So our answer will be using the intermediate, that is nothing but a skip welding. Skip welding, so that will reduce the total heat input, shrinkage, thus minimize distortion. Okay. Longitudinal distortion may lead to which of the following long plates? Option A, angular bending. B, buckling or bowling. C, increasing the thickness. D, surface cracking. Answer will be B. Longitudinal compressive stresses can cause buckling for the long slender plates. Okay. The transverse distortion in the fillet weld is mainly influenced by weld throughout the thickness, weld length, plate length, and ambient temperature. So answer will be weld throat thickness. So larger weld throat means more deposited material and heat increases the shrinking across the weld, thus transfers thus transverse distortion. So now we see the some numericals. Before that, we will just revise what our have teach. Okay. So for any for to find out the longitudinal shrinkage, how we can calculate is that the amount of the longitudinal shrinkage happen is delta L equal to 3 L by 1 10 to the power of 5 into T. Here is the delta L is the change in the dimension, change in the longitudinal strain, I is the current, L is the length of the well, and T is the thickness. All are in mm. So suppose if we have the current, we are using 200 amperes, and if we are using the a thickness of 6 meters, so we can easily calculate so that will be results in L by 1000. If suppose L is the suppose 2000 mm, that is nothing but 2 meters, then it will be the total length in the distortion will be the 2 mm. We can calculate it. So if we for the fillet welding, AW by AP 25 into AW by 80. AW is the area of the welding, AP is the welding plate. So if both of these will be less than 20, so then we can use this formula. So 25 into AW by AP, that is the total length change. Okay. Similarly, for the transverse shrinking, we can find out by the amount of the transverse shrinking. Here is the find out by delta W by 10T. Here is the delta W is the cross sectional area of the weld material, and T is the welding thickness. So a steel plate of length 1 meter is to be welded. If the average longitudinal shrinkage strain is this much, then what is the reduction length? So it is nothing but, as we seen here. Here it is, they have given the what is the longitudinal stress and total length. So we just have to multiply both of them to get the del L. Okay, that is the 1.5 mm. Next, in butt welding causes the transverse shrinking of 0.8 mm in the plate width of 400 mm. What is the transverse strain? So it is also similar to one. We can calculate by so change in the del T by total width, that is the 400, that will be gives the transverse strain. Okay. Heat input per unit length given by H equal to Vi by S. Okay. Here Vi is the voltage, I is the current, S is the speed. Okay. So if the voltage current remain constant, the welding speed uh, increases. What will happen? Half welding speed become half means it so it will be by 2. So what it will be, heat input is inversely proportional to the uh, speed. So it will be uh, reducing in the speed increases the heat input. So more shrinkage, that will result in the more distortion. A fully restrained weld develops a strain of 1.8 into 10 to the power minus 3. If E is the 200 GPa, the stress developed is, answer will be C. That is the how it is the stress equal to Young's modulus into strain, that is we can multiply it, we can get the stress, amount of the stress is the developed. The plate of the thickness 12 mm showing the shrinkage difference of 0.6 mm across the thickness, the angular distortion will be. So how we can calculate the angular distortion? The same. It will be, we have seen here, angular distortion formula you can apply. So it is the here they completely given the shrinkage difference. So that will be 0.6 divided by 12, that will be 0.0205 radians. The weld induced transverse strain 1 into 10 to the power of minus 3 in restrained plate. If E is the 210 gigapascals, the stress generated will be. It is the multiplication of the strain into the E. It is also like previous one. So next, two welding processes produce the heat inputs of 800 joules per minute and 1200 joules per mm. Sorry, 800 joules per mm and 1200 joules per mm. The ratio of the distortion. So how it will be? Distortion is directly proportional to the heat input. So that if heat input is more, that so we can just find the ratio between the heat inputs. That will be the rate of the distortion. The angular distortion in the welding joint is primarily due to uniform contraction across the thickness, unequal contraction across the thickness, external mechanical loading, phase transfer externally. The answer will be, as we seen, distortion only by unequal contraction across the thickness. So angular distortion occurs because of the top and bottom layers of the weld string unequally producing the rotation. Okay. Plate of the thickness 10 mm has a shrinkage difference 0.4 mm across the thickness. The angular distortion is, so answer will be, we can find out by dividing by shrinkage difference by plate thickness. That will gives the angular distortion. If the heat input increases, the angular distortion will be increases because the heat input is directly proportional to the distortion is directly proportional to the amount of the heat input. So answer will be the B, increases. Higher heat input results in the larger thermal gradients, more uneven shrinkage, greater angular distortion. Angular distortion is more severe in the thick plates, thin plates, same for the all plates, and depends only on the material. Answer will be thin plates. Thin plates offer less resistance to bending, so they undergo the larger angular distortion. If the angular distortion is 0.02 radians, the angle in the degrees is approximately, we have to convert that into radians into degrees only, that is by 180 degree by pi, that will give the 1.15. Increase in the weld size will reduce the angle distortion, increases the angular distortion, have no effect, reduces the heat input. Answer will be B. Increase the angular distortion. As the larger weld size, the more heat input, results in more shrinkage, that will give the more angular distortion. A plate of thickness 8 mm has the shrinkage difference of 0.16 mm. Find the angular distortion. That will be, we can find out by the shrinkage difference divided by plate thickness gives the angular distortion. Which method is more effective? To reduce the angular distortion? One is the increase the weld passes randomly using the double side welding, increase the heat input, reducing the weld speed. So answer would be B. Use the double side welding. So double side welding balances the shrinking on both sides, that's reducing the angular distortion. If the strain at the top surface is 2 into 10 to the power of minus 3 and bottom is 1 into 10 to the power of minus 3, thickness is the 10 mm, the angular distortion will be. So difference in the strain will be 1. So the strain, the difference strain into the total thickness, that will gives the total angular distortion. If the welding joint is fully restored, the angular distortion will be increases, decreases, becomes zero, reverse direction. If it is restrained means it is completely becomes zero. The restraint restricts the rotation, thus uh, reducing the angular distortion. Okay, restraint. Bowing, blowing in the welding plate is primarily due to transfer sinking only, non-uniform longitudinal sinking. I think it is also similar to the previous ones. Phase transformation, external loading. Answer will be B. Blowing occurs when longitudinal strain is non-uniform across the width, causing the plates to curve along its length. The buckling distortion in the welding is most likely when tensile residual stress dominates, compressive residual stress exceeds the critical value, and no residual stress existed, material is very thick. Option will be B. Compressive residual stresses exceeds the certain value. The twin plates under compressive residual stresses may lose stability, results in the buckling. So, critical stress for a plate is given by, so here A given, L by T given, and stress of the critical we can calculate by, I think it is just directly putting it to the formula. So, the twisting in the welding structure is mainly due to symmetric heating, unequal heating input across the width, uniform cooling, equals shrinking. I think it is also similar question. Twisting across when heat input and shrinking are asymmetric, that causes the rotation about the longitudinal axis. The slenderness effect on the buckling tendency increases with decreasing the length by thickness ratio, increasing the length by thickness ratio, increasing the thickness, decreasing the width. Option will be B, increasing the length by thickness ratio. Higher the length by thickness ratio, more slender plate, lower critical stress, that is easy to buckling. The plate of the length 1 meter has maximum mid deflection of 5 mm due to the bowing. Radius of the curvature is approximately r equal to L square by 8 delta. So answer will be length we know, that is 1 divided by 8 into mid deflection delta equal to 5, that we put, then we will get the radius of the curvature, that is the 25 meter. Which method reduces the buckling distortion? Increasing the heat input, using the thin plates, providing the stiffeners, and welding randomly. Answer will be C, providing the stiffeners. The stiffeners increases the rigidity, raises the critical buckling stresses. If residual compressive stresses 150 megapascals and the critical buckling stresses 120 megapascals, the plate will be remain stable, yield plastically, buckle, fracture. Answer will be C. When the buckling, why buckling occurs? When the residual stresses increases the its critical stresses, so that time it will buckle. So as the critical stress is the mm, one one critical stress is the 120 megapascal, but here applying compressive stress is the 150 megapascal, so it is more than that, so the buckling will be takes place. The twisting can be minimized by asymmetric welding, balance welding sequence, increasing the weld size, increasing the temperature gradient. Option will be B. The balance in the weld sequence ensures the uniform shrinkage that preventing the twisting. Okay. Two plates having the L by T ratio, like one is the 50 and one is the 100. Ratio of the critical stress will be, yes, see, critical stress is directly proportional to the 1 by L by T square. So that means uh, the stress one is the 100, so that the T will be, answer will be C, that is the 4 is to 1. Why is that? It is, yeah, so if we put the values here, it will be become 4. Next, the most effective way to control the welding distortion is increase the heat input, minimize the heat input, increase the weld size, use the thicker electrodes. Answer will be B, minimize the heat input. So distortion is proportional to the heat input. So if reduce the heat input, it will minimize the thermal expansion and contraction. The welding speed, if the welding speed doubles, the distortion will be, yeah, so welding speed is inversely proportional to the distortion. If the welding speed increases, distortion will be reduces. That means answer will be B. So as the welding speed increases, the lower heat input per unit length, that reduces the less distortion. Use of the right clamps during the welding increases the distortion, eliminates the residual stresses, reduces the distortion but increases the residual stresses. Yes, no, or yes, no effect. Answer will be C. So clamping will reduce the distortion but increases the residual stresses. So those lock-in stresses we have to remove by post-heat treatment processes or pinning process. Next is the, which is the welding technique best reduces the distortion? Continuous welding, random welding, backstab welding, increasing the weld length. Answer will be backstab welding. In backstab welding, we do the one pass in forward direction, one pass in backward direction, and so that heat distribution will be uniform. So that will reduces the distortion and residual stresses. If the heat input is reduced by 25%, the shrinkage strain reduces from, so if heat input reduced by 25%, so the total heat input will be 0.75%. So the stress is, it is directly proportional to the shrinkage strain is directly proportional to the amount of the heat input. So that means the strain also will be reduces by 25%. That will be 1.5 into 10 to the power of minus 3. The preheating reduces the distortion because of, so now we are coming to the section of how to control this distortions. So bowing and longitudinal bending, when the weld line does not coincide with the neutral axis of the weld structure, the longitudinal shrinking of the weld metal induces the bending moment, results in longitudinal distortion of the structure, known as the bowing or crumbling. Okay, amount of the distortion depends on the resistance of the member to bending. The little distortion is produced by intermediate welding due to the fact that longitudinal stress does not reach a high value in a short intermediate weld. Okay, so distortion of the welding specimen often leads to, I think it is a lead to undesirable deviations from the design dimensions. Hence, we have to minimize it. How we can minimize it? Residual stress and distortions to large extent behave contrary way. That means if the stress are if distortion is limited, the stresses will be generated, or if distortion is happening, the stresses will not be present. So it are often desirable to have low value of both residual and distortions. So annealing may be carried out, however, the wrapping may occurs in case of improper or uncontrolled annealing. Okay, so we have to use the proper parameters. So what is the methods we can control the distortion in welding is that first one is the least root method gap. So we have to provide the least amount of the gap uh, at the root section. So what is the root? As or we can I will show. So here is the root. This is the root. Okay, we have to provide the least gap between this for this root region here. So that is the one method. Next is the proper tack welding. Next is the narrow groove section. Next is the direction of the welding, least metal deposition, welding sequence, and backstep welding and counterstep welding. So these are the different methods how we can prevent the distortion effect, such as narrow groove section. In narrow groove section, groove section should be narrow as particularly feasible to permit the small amount of the possible heat input. The filler material is conjunction with the highest possible heat concentration. Okay, selection of the proper groove design. We have to provide a we have ultimately is that we have to provide the less heat input so that it will reduce the distortion. Or if we provide the concentrated heat, I mean it is a certain welding process like laser beam welding, electron beam welding. In that case, the energy concentration, the weld pool will be smaller. So in that case, the distortion will also be less. Next, direction of the welding. It should be always from the point of the restraint and towards the point of the maximum freedom. Okay, it should be from the where we have done the clamping their region to what is the free region. Okay, and least weld metal deposition. So no excess weld metal should be deposited. Okay, there should be the proper. Next, weld sequence. Both sign and magnitude of the deformation can be controlled by using the proper weld sequence. For job of the large surface area consisting of several plates and transverse seam should be welded first, followed by the longitudinal seams. Okay, first we have to do the transverse welding, then we have to do the longitudinal welding, longitudinal sections for a very large surface area. Suppose if I have to do welding these regions, so first I have to do this transverse region first, then I have to go for this longitudinal one. Next is the backstep welding sequence, used for the contracting the weld shape, shaped opening and closing, the rotational distortion of the weld grooves. The track weld first made and a weld layer is subsequently deposited in the backstep sequence. Finally, remaining the layers are applied. Okay, backstep welding sequence is to minimize the proper heat distribution and to minimize the distortion. So, the preheat treatment reduces the distortion because of it increases the temperature gradient, reduces the temperature gradient, increases the cooling rate, increases the shrinkage. Answer will be B. It reduces the temperature gradient. The preheat treatment lowers the temperature difference, more uniform contraction, results in less distortion. The angular distortion is proportional to the temperature gradient. If the gradient reduces from 300 degrees centigrade to 150 degrees centigrade, the distortion will become option A same, option B off, option C double, option D 1/4. Answer will be B off. That is the theta equal to theta directly, as the theta directly proportional to the change in temperature. Uh, Once we temperature become off, the distortion also will become off. So some of the crucial points to control the distortion is that first reduce the heat input, increase the weld speed, use the proper sequence like backstep or skip welding, apply the clamps and fixtures, use the balanced welding, that is double side welding or like that, and preheat treatment. These are the some of the methods to control the welding distortion.
Mm.